Hello and welcome to this session. Today, we'll explore practical probability theory and its key applications in data science, from foundational concepts to real-world machine learning examples. Read your tasks carefully and focus on command verbs. Command verbs include explain, define, and describe. Ensure your work is well-referenced in Harvard style. Use proper headings and subheadings for a professional look. Keep plagiarism below 20%. Choose a specific organization to start your assignment. Write an introduction about the chosen company. Use proper headings and subheadings to present your document professionally. Number your figures and tables for clarity. Follow the assignment presentation numbering closely. The unit focuses on practical probability theory for data science. Key areas include probability fundamentals and distributions. You'll explore sampling, bias, and statistical testing. Applications in data science will be highlighted. This knowledge supports data analysis and machine learning. Imagine working in a data analysis team at a car hire company. Your role involves analyzing data and supporting machine learning. You'll improve business insights through data-driven decisions. Tasks include presentations and reports with specific criteria. Your work must meet pass, merit, and distinction levels. Task 1 involves explaining independence and sampling bias. You'll cover the central limit theorem and Bayes' theorem. Merit tasks require understanding correlation versus causation. Distinction tasks focus on Bayes' theorem in machine learning. Each concept is crucial for data science applications. Task 2 focuses on explaining normal and discrete distributions. You'll differentiate between Poisson and exponential distributions. The normal distribution is a bell curve with equal mean, median, and mode. Discrete distributions deal with count-based values. Poisson counts events over time, while exponential relates to time between events. Task 3 involves explaining sampling methods and moments of distribution. You'll explore tests and their applications. Distinction tasks focus on understanding kurtosis. Sampling techniques include random, stratified, and systematic methods. Moments cover mean, variance, and skewness. Independence means one event does not affect another. The formula is probability of A and B equals probability of A times probability of B. Sampling bias occurs when data is not representative. It leads to incorrect conclusions and loss of reliability. Understanding these concepts is essential for accurate data analysis. The central limit theorem states sample means form a normal distribution. It is vital for statistical testing and data analysis. Bayes' theorem is used for conditional probability. Applications include prediction and classification. Mastery of these theorems enhances your data science skills. Correlation refers to a relationship between variables. Causation indicates a direct effect. They are not the same and should not be confused. Bayes' theorem is used in classification models within machine learning. It helps in predicting customer behavior effectively. You've now explored practical probability theory for data science. This includes key concepts and their applications in real-world scenarios. Enhance your data analysis and machine learning capabilities with these insights. Should you need any assistance, please send a WhatsApp message to 0748 436 1688. We're happy to help. Thanks for your participation, and see you next time.